G'day guys, Socket here. Today we're going to continue on with our amplifier series, and in today's episode we're going to open up all the amplifiers and take a good look inside. I hope that by the time we get to the end of today's tutorial you'll have a pretty good idea how a signal flows through the amplifier to the output section and gets amplified to be able to drive your speakers, and how the power coming into the amplifier is converted into AC and then split into DC to supply the voltage for your power rails. But enough talking from me. Let's go open up some amplifiers and take a good look. Okay, so today we're going to look inside an amplifier, and we're going to keep it pretty high level, just have a look at the major parts that make up an amplifier and the components that kind of run it, and then later in the tutorial we're going to drill into each of the components and see how they work, and then in a future tutorial for those that want to get into all the details and all the technical side of how amplifiers work, we're going to go dive right down into the nitty-gritty and work our way through, almost circuit by circuit. But for today we're just going to explain the basics. So first of all, I'm not an electrical engineer or anything like that. This is not my field of expertise, but I'll do my best to kind of explain what's going on. So we're going to use this Sundown monoblock amplifier. It's laid out pretty well, and it's easy to see all the major sections. So to start with, the power supply comes in on these blocks, and the speakers come out on these connectors here. So this part of the board is basically the power supply section of the amplifier. The power then goes into these big black capacitors, and then we have down the other end, the audio signal comes in through these terminals. This section here is the input section, or the op amp, that handles all the manipulation of the input signal. And then this middle section here is the output section, where the input signal is amplified, and we have sufficient power attached to it to actually drive the speakers, and that power is then sent down these cables to the speaker outputs and then sent out to the speakers. So let's have a quick look at each of these areas and how they kind of work. All right, to start with, we're going to have a look at the power supply section of the amplifier. So as we said, the power is coming in on these terminals here. So we've got the ground and the 12 volt and the remote, and they're being sort of fed down this bus bar here. Now a bus bar is just, if I sort of zoom in on one of them, this thing here, they're big metal plates or bars that basically carry lots of voltage, from one part of the circuit board to another. All right, so the power's being carried along this bar and being fed into these capacitors. So the job of the capacitors is to basically act like water tanks and store a certain amount of electrical charge, and to kind of smooth out any lumps and bumps in the power supply, right? So from there we have these two big colourful wound donut shaped things, which are actually the transformers, and you can tell the difference between a transformer and what we call a coil, because these have multiple numbers of wirings. So in this case we've got the copper, the red and the green wirings, and so the purpose of the transformers is to take the DC current that's coming in from your car alternator or battery and convert it into alternating current. Now the way that they do that is down here is a tiny little chip called the pulse width modulator, right? And what that does is it basically controls these power transistors or MOSFETs, and I'll take these little heat sinks off in a moment so you can see them. But basically what it does is it switches these MOSFETs on and off extremely fast. So somewhere around about 25 kilohertz or 25,000 times a second, and in doing so changes the direction of the the electricity flowing through these coils and creates an alternating current power supply from these transformers, right? Now from there, the power is sent through to these things called rectifiers, which basically split that alternating current into a negative and positive rail. And then the positive rail goes up to one set of these capacitors for storage, and the negative rail goes off to another set of capacitors for storage. And in between we have a bunch of other components that are going on, so diodes and resistors and transformers and other things, which, as I said, we will have a look at later in the tutorial. So from that's the power supply section. We've now got power sitting in these capacitors ready to help support the output section of the board. So let's have a quick look at the input section of the board. So the signal comes in through the inputs, or your line inputs, or your speaker level inputs, and then here are all the pots and capacitors and things that are involved in manipulating the signal. So if we swing around here, we can see all the dials for the gains, the crossovers, the bass boost, and all that type of thing. So this whole section here, this blue section here, is essentially where the input signal has is manipulated by the op-amp circuitry, right? And so we can see in here, we've got integrated circuit chips. We've got these potentiometric pots, I think they call them, a whole bunch of resistors and capacitors and other things, which are involved in manipulating the signal and cleaning up any noise and all that type of stuff. But eventually the signal comes to this device here, which is your driver card, right? And so in the middle of the driver card is another pulse, if I can just get that in focus, another pulse width modulator, which is involved in switching on and off the output transistors which power or provide the power for the speakers. And so unlike the pulse width modulator that's driving the transformers, which is kind of a set frequency, this pulse width modulator switches on and off in conjunction with this input signal. So where we have peaks and dips and things like that, it will replicate that and send that signal to these drivers that will amplify the voltage of the signal. So a very weak signal out of the pulse width modulator to a very strong signal coming out of these drivers, right? And those drivers then basically, hello, Bella is, what are you up to, Bella? She's chasing something. Anyway, thank you. Sorry about the interruption. So that driver signal is basically controlling these MOSFETs. Yes, thank you. And switching these things, switching on and off, once again, very quickly, somewhere between 20,000 and 110,000 kilohertz, 110,000 kilohertz, 110,000 hertz, so much faster than the power MOSFETs. Basically in time with the input signal that's coming from the input section of the amp. Now we've got pairs of output MOSFETs, so a pair to handle the negative rail and a pair to handle the positive rail, and we've got them on kind of both sides. And then they basically draw extra electrical power from these rail capacitors and add amperage to the output signal, which is then kind of cleaned up and added to in this section before the speaker level signal, which is high voltage and high amperage, flows down these cables and then out to the speakers to drive them. So that is a super quick rundown of how the path flows through the amplifier and the different sections that make up a common car audio amp. Okay, before we move on and start looking at some of the other amplifiers, I thought we'd just look at some of the major components that make up your car audio amplifier. And to start with, just working our way around the block, so to speak, let's just start with these things called capacitors, right? So a capacitor is a bit like a little battery or water storage tank. It's there to provide temporary power to things, if your power supply gets interrupted, or more importantly, to smooth out the power supplies. They come in lots of different shapes and forms. These things down here are also little mini capacitors. You can see a few smaller ones down here. But you generally have capacitors associated with the power side of the amplifier, and these big rail capacitors that are basically providing the negative and positive electrical energy for your output transistors, which we'll talk about in a moment. But yes, that is capacitors. The other types of things that we can kind of see here, and there's lots and lots of them, right? These little tiny coloured things, and let me just zoom in on a bigger one. Here we go. So these are called resistors. Right? You can tell they're sort of cylindrical with sort of colour bands on them and things like this, and they're basically like a little valve, only allowing a certain voltage to pass through in one direction, right? So they control voltage in the circuits. Then we have things called diodes, and I don't think I have a good example of a diode. Let me just see if I can find one here. All right, so way down here, this tiny little thing here. I'm not sure if it can get it into focus. Actually, it's that small. But it's just got one coloured ring or a stripe or a cap on one end. So a diode is kind of like a one-way street. It will only allow electrical current to flow in one direction. Right, so it's like a one-way valve. Then we have things called transistors. And so here are some transistors. These are the power transistors. So we've got 2, 4, 8 of those. And you can tell they're a transistor because they've got, in this case, three legs. And these are a special kind of transistor called a MOSFET. Essentially, these switch on and off super fast, about, as I said, 25,000 times per second, and cause the power in these transformers, these big wound, colourful looking things, to go back and forth, right, as they switch, which then creates the alternating current. So so the reason that I've taken this heat sink off, but a lot of them have these metallic plates sort of bolted to them, and they're usually bolted to the amplifier's heatsink, right? The fins on the side of the amplifier, because they get extremely hot because they're switching on and off so fast, right? And they produce heat. So to keep them from sort of burning out, they've got to be able to dissipate that heat, and hence why we have some sort of heat sink or something on them to keep them kind of cool. So we'll talk about how transistors work. In this case, they're providing a role to do switching. Transistors are also used to amplify signals, and control voltage, a bit like a valve. Have several different roles. We've also got these ones here. These are the output transistors. These are the things that actually drive your speakers. So there's 2, 4, 6, and 8. So we'll have a look at those a little bit later, but you'll see them in other parts of the circuit board as well. Here's another one, a couple more down. I'm sure they're transistors. There's also a special kind of transistor called a rectifier. Now I've pulled the heatsink off this one so you can see it as well. But essentially what this is doing is taking the AC power supply from the transistor, and it's converting it back to DC and splitting it into positive and your negative rail voltages, right? So that's what these little rectifiers do. We'll look at all of that under the topic of transistors and how they all kind of work. The other thing I just want to have a look at is these chips. So integrated circuit chip, so this one here, which is the pulse width modulator. And so this is involved in creating the switching signal to turn on and off the MOSFETs, which in turn turn on and off the, change the direction of the electricity flow to the transformers to generate your AC power from your DC power supply, right? You know, as I said, these produce a square wave, a positive and a negative square wave, and yeah, and in this particular case, this integrated circuit has a bunch of capacitors and resistors and other things to clean up the signal and, you know, all that stuff. Yeah, it's generating the square wave signal that drives all of this. And we have a second one that's over here on the driver board, but this one basically amplifies the input signal going through this op-amp section, and it's then magnified or amplified by these driver integrated chips, as we spoke about before. We're going to have a look at what a pulse width modulator is and how that works a little bit later as well. The other one that I probably haven't talked about much is the transformer. So, you know, in this case, this one has two of them, and as it provides the alternating current supply that you need to drive your drive the speakers, and yeah. And once again, we'll have a look at how these special types of transformers work and why they're a donut shape, right? Sometimes they're not, but in most car audio applications they are. Not to be confused with these things. I think I called them coils before, but they're actually called chokes. They're used to sort of clean up interference in the electrical signal. And then we have, let's see, what else haven't we talked about? I think we've all of these integrated circuits here, these variable pots, lots of resistors, capacitors. Yeah, I think we've covered most of the major components. Probably the only other one to talk about is this. It's basically a switch. And when it gets to a certain voltage, it turns on. When voltage drops too low, it turns off. And this major switch is responsible to make sure that you know, we've got power going to the speaker outputs. All right, so now we've had a closer look at the, you know, capacitors, diodes, resistors, transformers, you know, all of that type of stuff, integrated circuit chips and things. Let's go and have a look at some of the other amplifiers and how they're laid out. All right, so this is our second of our mono blocks. I think this is the, oh yes, option audio mono block. And once again, it's a pretty compact design. I've tried to have the settings in this close same, all in the same orientation. So we've got the power supply on this side and the speaker outputs on this side. But we should be able to see this same type of componentry that we saw in the first amplifier. So here are the power supply capacitors, you know, so power coming in, filling up these capacitors. We've got the little pulse width modulator down here. So this is the power supply driver section, right, with all the circuitry. That then drives the MOSFETs, which are in behind here. So we've got two of those, and that's driving the transformer. The power is then going to the rectifier, which is here, and then filling up the rail capacitors, you know, with the positive and negative power supply, right? On the other side, we've got our speaker inputs. Once again, here is our input section with the, you know, controls for crossovers and things like that, and all the circuitry that's, you know, involved in manipulating the signal. And then here's this tiny little driver board over here with the pulse width modulator and the driver. And once again, they're driving the MOSFETs for the output section over here, and you know, running it through a choke, and other things to sort of clean up the signals, and then the power's being sent, the output transformers or MOSFETs are drawing power from these caps and supplying power to the output section of the speakers, right? And off it goes. So exactly the same type of path moving through the amplifier. Now, I'll just look at a couple of things here. So before we were talking about a diode. Let's see if I can just zoom in on this little guy here. So you can see he's got a grey section with a black. So you can keep that in focus. So that's a diode, bigger version, and it allows electricity to flow in one direction, right? Otherwise, you know, this thing has capacitors and you know, resistors, resistors here, you know, transistors. Here's another little transistor there, 3 legs. Oh, here's a better example of the diodes, just here. Can I get that in focus? I think. Yep. So yeah, all you're basically the same componentry in all of the amplifiers, just in different layouts. Okay, let's go take a look at the next one. Alrighty, from the very simple to the very complex. So this is the Zapco 1100.1 monoblock, and this one's been damaged. You can see a fair bit of scorching and things that's happened down here and over here, you know, all burnt, where the MOSFETs have basically overheated and burnt out. And generally when amps go down, this is quite common for the power transistors to get burnt out, and then generally require all need replacing, and this bus bar would need to be replaced and stuff like that, but it's out of my skill set. But anyway, we're not here to look at that. What we want to talk about is how things are moving through this amplifier, and the so in this, once again, we've got the power supply over here, positive, negative, and the remote, and these are the speaker output connectors right over here. All right, so once again, we've got the power capacitors along here, so there's 10 of those. We've also got some chokes, which I assume are to clean up the power supply coming into the power supply section. Once again, we've got 2 large transformers. We've got some pretty chunky looking resistors here. But the main circuitry, once again, here is the pulse width modulator down here in the middle, a couple of other driver chips or something going on. And these are, see these little things in here? They are resistors, but they're a different type of resistor. They're a surface mounted device. So they're a modern version of the little stripy things, like modern version of this little guy, right? And they're extremely, get that into focus, they're extremely small. But yeah, we'll look at those later when we talk about resistors. So yeah, once again, the pulse width modulator is switching on and off the MOSFETs, and we've got 1, 2, 2, 4, 6, 12 of those on this particular amp, which is switching the transformers on and off, changing the direction of the electricity flow. It's then going to the rectifiers, which are these ones here, and then being stored in these rail caps, right? So we have 4 of them, negative and positive. Once again, we've got some chokes here to clean up the electrical signals. And then we're into, I guess, the output section, sorry, the input section of the amplifier. So we've got the audio input coming into here. Now, in this case, we don't have all of this crossover and bass boost stuff. We've just got a simple gain knob. So all of this stuff here is associated with the input signal and the output signal, right? So in here, I think, not sure where the pulse width modulator chip actually is for the output side on this particular board. Maybe it's under this fan, I'm not 100% sure. But we've got a bunch of output MOSFETs, to drive the speakers, drawing power from these rail caps. And we've also got some other transistors down here which are probably to do with supplying power to this particular section. So this is a pretty heavy duty amp, but once again, you know, yes, the resistors and things look different. You know, we've got a few more transistors and things in here. We're using lots of these surface mount resistor things, but you know, just probably more for space than anything else. But you know, the components and things are largely the same as in the other amplifiers that we've seen. Okay, so next we have the JLE400, I think it is. So once again, we have the power supply section up here, the positive, negative, and the remote. And, you know, we've got the power capacitors over here. We've got the transformer over here. I'm just looking for the pulse width modulator. I think it's this little chip here. Once again, the MOSFETs here, and the resistor and the capacitor, I think it is capacitor, yep, that are, I think they're called gate drive, not gate drivers, gate something or others, that basically protect each of these power supply transistors, right? And then once again, just zooming in, here's a great example of some diodes that we're talking about before. You can see, you know, they've got a silver end showing the direction that the power can flow. And of course, this is also using these surface mount SMD resistor types. We also have here a variable resistor, so able to, for example, change the resistance value just by turning the dial. Okay, so that's the input section. The rectifiers, I think this is the rectifier over here, and then that's converting it to DC and then sending it to the rail capacitors, in this case 3 for the left and 3 for the right. On the input section, once again, this is where the signal is coming in, and we've got a bunch of controls for the bass boost and all that usual stuff. But this time, some of the circuitry is buried underneath this vertical card with these, these crazy connectors going on here. So we can't really see much going on underneath there, but that's all the circuitry for manipulating and amplifying the input signal. And then we come to the output section, which is a little bit different. So when we have, so far we've been looking at monoblock amps, but when we're looking at multiple channel amps, and this is a 2-channel amp, you'll find that the output section is often duplicated. So in this case, we have one for the left front, one for the right front, one for the left rear, and one for the right rear. So we basically got a 2-channel amp with a left and right, and a left and right. And you can see that the circuitry is basically, there's 4 copies, and they've got their associated MOSFETs, for their output transistors, right? And some bus bars that we can see here, and some fancy looking bus bars here as well. But otherwise similar circuitry. Now some of these white blocks are actually a different form of resistor, so different style. And these tiny little black objects, which you see all over cards, circuit boards, are actually transistors. And if I go down, I'm not sure you're about to see, but if you look closely enough, you'll see they've got 3 little legs on each of these things. So they're transistors. So there you go. That's the JL board. All right. So next up is the JL amplifier. A pretty good quality build, this one. So let's see if we can just have a quickly look at the section. So here is your power supply. We've got a a choke here to clean that power supply up, and then of course your power supply capacitors. The pulse width modulator, where is that? Might be this one here, or these two here, not sure. Looks like that one. Well, it's one of those two. You've got your MOSFET transistors over here, and on this side looks like the rectifier's missing down on here, but anyway, here's your transformer, the capacitors to store your rail voltage, a few more chokes to clear things up. You know, once again, your output transistors. Here are your driver cards. So this is a 2-channel amp from memory. So you've got, you know, your output section here on the left and your output section on the right. Yeah, quite a lot of componentry in there. Lots and lots of resistors and things. But yeah, really well laid out. But yeah, I think you know, as I said, power section, your input section over here, your output section with your MOSFETs or your output transistors, you know, your rail caps. I think you're starting to get the idea of you know, how something kind of flows through the amplifier. So let's go take a look at the next one. All right, now we're going to look at something a little cheaper or a little old school. So this is the precision audio amplifier. The power supply is coming in here, and your speaker connections are there. But once again, we've got a little fuse down here for your power supply. We've got our power supply MOSFETs along here. Pretty sure that's those there. One capacitor for the transformer. The pulse width modulator, I can't really see that. Maybe, I don't think it's that. Maybe it's under the card, not 100% sure. But the power then going off to your rail caps, and then you've got your inputs, you know, all of that stuff. And here's this, here's the little pots for changing the gains and things like that. And then you've got this crazy little crossover card that kind of plugs in, just going into there. This is another set of outputs, bypass outputs for your speaker signal. And yeah, the rest of it all looks pretty, oh, this must be the pulse width modulator here. Looks like it. But then, you know, as always, we've got your output transistors over here, running along here, supplying your speakers over here. And these are the resistors and things that, you know, are supplying the voltages to your output transistors, right? But once again, lots and lots of resistors, lots and lots of resistors and tiny little transistors, capacitors, integrated circuits and things. Yeah, so there you go. Okay, next up we have the Maxima from Thailand. You're probably getting the idea by now, but here is our power supply. No, it's not actually, sorry, that's our speaker outputs. This is our power supply over here, so positive, negative and remote. The capacitors on the power side, looking for the pulse width modulator chip, can't see it straight away. Might be this little fella down here, not sure. Once again, the MOSFETs for the turning on the transformer on and off. Here's the transformer here. Another great example of some diodes that we can see here. Zoom right in if I can. There we are, diodes. Love them. Yeah, but you can tell this is a budget kind of, you know, the winding on this is not great. and it looks a bit cheaper. Actually, here we go. We found our little pulse width modulator. It's on its own little card over here. Yeah, so there you go. It's got its own little card. And then, of course, here are the rail capacitors holding the charge for the output transistors. Now, once again, 2-channel amp, the input section, and all the circuitry in there. Driver card mounted on the top. And then you can tell that this is a 2-channel amp because we've got 1, 2, 3, 4 output sections with their own little MOSFETs. And it kind of explains why, when you see, you know, like the Zapco had, I don't know, 8 or 12 output transistors, and this one only has 2 per channel. The number and number of MOSFETs or output transistors that you have, and the more power you can drive into your speakers. Okay, so if you were bridging speakers, for example, instead of, you know, having 2 output transistors per channel, you'd have 4, and of course double the power, right? That's kind of how it works. But once again, you know, using these surface mounted, can we zoom in properly, these surface mounted resistors, a few transistors and things there. You can see their 3 little prongs, and you know, these big high voltage resistors. Yeah, so that is the budget Maxima. Okay, well, lucky last, this is the Fusion 4-channel amplifier. This is a really interesting one because it's a bit of an old school type of amp. It's got a separate input section card, and of course, being a 4-channel, you can see that we've got this thing broken up into kind of 8 sections. So we've got, you know, 1, 2, 3, 4, 5, 6, 7, 8, right, for left and right. And you know, you can see those kind of sections are kind of duplicated. So this whole area here is dedicated to output. This is your power section, output section, and then your signal input section, right? So as always, we'll sort of work our way down through, sort of down along the chain. So your power supply, you know, starts down here. So negative, positive, and the remote, and these are your speaker out lines. Once again, we've got some chokes here to clean up the signal, some capacitors for the input power section, transformer, the MOSFETs, I should say. So we've got 1, 2, 3, 4, 5, 6, and you can see they've got the heat sink screwed down to the top of them, and they're firmly bolted to the amplifier heat sink. Right? Now, on the other side, we have the rectifiers, and yeah, you can see if I zoom in, you can see the labeling. You know how they're splitting the positive and negative direct current wave. Here are the output rail caps, so coming off the rectifiers. And then, of course, down on the input section, all the usual control pots, and the circuitry that goes with manipulating the signal, and then the signal is transferred to the output section. And what I don't see a lot of is integrated chips, whether on the other side of the board, I'm not sure. So they're relying heavily on a lot of these transistors. Yeah, not sure. But yeah, a very cleanly laid out board. As you can see, a bit of an old school style. So they've actually got these, you know, wires running from different sections. You know, not a lot of you know, circuit board traces that we're used to seeing in more modern boards, right? But yeah, really, really interesting. I guess this is probably the board that is most easily able to see the, you know, the power section, the op amp or the input section, and the output section, so cleanly laid out, and and the various components, right? The power capacitors, the transformer, the MOSFETs, the rectifier, the rail capacitors, and all the output transistors. Yeah, really interesting layout. So yeah, that brings us to, I guess, the end of all of the amplifiers that we've got to sort of poke around in the insides. So what we're going to do in the next episode is really drill down and have a look at how these capacitors work, how the rectifiers and the output transistors work, and really get into the electronics and the design and what these components actually do. And then once we've got an understanding of that, we're going to I know I've walked through how the sort of signal flows around, but we're going to walk through in very great detail and explain how these amplifiers work in both A, B and D class. Looking at exactly, well, how does a rectifier take a AC signal and split it into DC negative and positive rail voltages, right? And details like that. So if you're interested in all that techie stuff, be sure to tune in to a couple of episodes from now. So there we go, guys. That brings us to the end of today's tutorial. I hope you learnt something about how amplifiers work. In the next episode, we're going to look at how diodes and resistors and transistors work, how they're made, what they actually do, and electronically how they operate. And that will be great background information for the following tutorial, where we're going to deep dive into how amplifiers actually work as the signal and as the power moves through each of the stages of the amplifier itself. So looking forward to that one. But in the meantime, guys, thank you so much for watching. As always, if you've got questions or comments, please feel free to throw them down below. Otherwise, I will catch you in the next episode.